Anyway, we have discussed the algorithm using binary searching for finding the appropriate insert position of a particular target value inside a sorted array of values such that the array will still remain sorted, right? And I have created the file, and I have created the class and function and everything. I have also written the code for calling that function as well. Now let's just go ahead and let's write the logic here. Now first of all, here since we are going to use binary searching, let me just start with defining couple of variables which are nothing but start and end, which is nothing but start start will be initialized with 0, and the end will be initialized with last index that we have on the array. Along with that, I will also define one variable middle. Here we will simply run a loop as long as the start is less than or equal to end. Why am I typing so bad today? Start is less than or equal to end. What we will do, we will calculate the middle. To calculate the middle, what again we will do, since the division will give us floating point numbers, we will floor it. So middle will be start plus end divided by 2. Okay, once we have the middle, whatever the value we have at this middle index could be equal to whatever the target we have been given, right? In that case, we can simply insert the value at that particular index itself, since the value is already available. So here we can simply return middle itself. If this is not the case, what are the other scenarios that we have? The value that we have at the middle index could be greater than the target value or lesser than the target value. So based on the condition that we have, we need to restrict our searching either on the left part of the array or on the right part of the array for finding the appropriate position. So here, if at all the value we have at the middle is greater than whatever the target that we have been given, in that case the middle value is greater than the target value. So the target value can be inserted somewhere on the left part of the array. So to continue that search, the left part of the array, what we will do, we will simply update end with middle minus 1. Obviously, if this is not the case, the value we have on the middle is lesser than the target. So the value can be inserted anywhere on the right part. To continue the search for the appropriate position, we will simply update start with middle plus 1. Once we run this while loop completely, right, whatever the value we have inside this start index will basically represent the appropriate insert position of this particular target value inside this sorted array. So here we will simply return start itself. Okay, so that is the simplest implementation of the finding of appropriate insert position for a particular target value inside a sorted array that we have been given, such that even after insertion that array will still remain sorted. Okay, anyway, we have also written the code for calling that function also, right? Now let's just call this function and validate the results. Here the array that we have passed is 1 2 3 4 5 6, and the target that I want to insert is 5. 5 is already available, right? It is available at index 0 1 2 3 4. So the value of 5 can be inserted at index 4. So if I run this code right now, the output should be 4, which is what we have gotten as well. Okay, so let me just clear the output once again. And here, instead of like this, the array that we have is 1 2 and 6. Now I want to insert 5 in it. So 5 can go before 6, right? 6 is available at index 2. So value of 5 can be inserted at index 2. So if I run this code now, 2 is what we have got. Similarly, let's just assume the value that I want to insert is minus 5. Minus 5 should go before 1, right? Because it is the smallest value that we are trying to insert. So if I run this output code now, output should be 0. That is what we have got as well. Let's just say the array that we are passing is empty. There are no values at all. So obviously the output should be 0 in this case as well. 0 is what we have gotten to here too. Okay, so whatever the logic that we have written for finding the appropriate insert position in a sorted array for a given target value is working absolutely fine. And we have written the effective, optimal solution using binary searching technique.